fully integrated 3D electrical harness routing application that allows users to design and route harnesses in complex assemblies. Built upon the NX routing applications architecture, the electrical routing tools provide electrically smart features and functions to automate the design, modification and analysis of the wire harnesses. NX electrical routing enables integration with all electrical disciplines, including systems design, logical design, PCB design, physical design, electrical analysis, manufacturing, installation, service documentation and service delivery. NX electrical routing consists of 3 modules. The first module is NX Routing Base. This includes the general capabilities to place parts, manage libraries with path creation and editing functions. NX Routing Harness allows for the importing of net lists, calculating bundle diameters and wire lengths. It can identify minimum bend radius violations and produce design and manufacturing documentation such as formboard. NX Routing Cabling supports conduits and raceways. It can facilitate the production of design documentation such as 2D representations of cable tray layouts. NX Routing Base is the base electromechanical routing module. In this demonstration I'll be routing wires for a motor control system in this tile stacking machine. To see the components I first need to open the door of the control box. Parts such as connectors can be placed in the assembly using the standard assembly functions or the routing place part command. Parts can be selected from the file system, a library or through parametric selection. Here the connectors are placed using predefined or qualified smart connection ports. These ports contain information on how the connector is located and orientated. Parts have the connection ports added to them by using the qualify part command. First, a fitting port is added. Fitting ports are used to connect devices or terminate a routing path. The port is located at the middle of the face. Next, the port direction is defined away from the connector. An orientation is required as this connector cannot rotate. Where the wires leave the back shell, a fixture port is used. Fixture ports do not terminate a wire as a fitting port does, but allows the wires to pass or slide through the port. As before, a location and direction is selected. As the wire is to pass straight through the hole, we can define a straight section of the wire where we built 20 mm from the connector and 3 mm into the connector. A multi-port is added where multiple pins need to be connected. As before, the location, direction and orientation are selected. Extension and cutback values are used for the create terminal function to strip and display the wire terminations. The extension value provides a 15 mm straight section from the pins, and the cutback length of 40 mm strips the insulation on the harness. The individual pins are defined and located. The pins are numbered 1 through 9 and placed. The connector is now qualified and ready to be used in an assembly. Paths are routed between points in an assembly. Segment shapes can be defined as straight, circular or spline. A spline may best represent any flexible route, including wires, cables and hoses. Here a spline route is being placed from a port in a connector through 2 clamps to another connector. A temporary stock of 5 mm is added to the route curve. The shape of the spline can be dynamically altered by modifying the extension values on the ports. Additional paths are connected by simply selecting any point on an existing path and then continuing the route. As ports have a direction, the direction can be flipped to give the required result. The path continues through clamps towards the motor unit. Extensions are edited to provide more cable slack. Once placed, route curves can be edited to add additional points. These points can then be moved to improve shape and location. The route is now complete with temporary stock. NX Harness allows the user to import and combine schematic and logical information into NX. Once combined, the connections can be displayed, bundle diameters and lengths calculated. Two harness navigators are available. The component navigator on the right shows the device connector association. The connection navigator below shows the connections and their logical path. The connection wizard allows the user to create connections through an interactive interface. The connection name is entered in the first panel. The from and to connectors are selected and given their logical names. The wire type is selected with colour information. When completed, the wire is shown. When repeating the wizard for the next wire, the logical information is maintained and only the new parameters need to be input. Logical net lists can be imported from external text files. These can be from Excel spreadsheets or extracted from NX schematics or other schematic software. The import-export formats, navigator displays and filters are user-definable. The component file is imported into the electrical component navigator. Once imported, the logical information is assigned to the NX component files. Where possible, the matches are made automatically. Then the remaining components can be manually assigned. The netlist or harness file is imported into the electrical connection navigator. The logical connections can now be displayed in the 3D model. The auto route command will process the connection information, replace the default stock with a recalculated bundle diameter, and produce the wire length values. The overstock command adds stock that represents some form of mechanical attachment or protection. For example, it could represent tape or flexible conduit. Here an overstock is added between two clamps. Wires can be stripped back to show each wire at termination. Only those wires connected are shown in this example. The form board is created from the harness level. From within the Create Form Board command, a drawing format is chosen and a representation of the straightened harness is produced. Inputs such as cut length roundup and default branch angles can be selected. The main run can be modified from longest or thickest or user-defined. Once created, the form board segments can be shaped to suit the drawing or manufacturing requirements. In this case, radial bends are being added to the segments. The drawing layout is opened and views added. User-defined pin lists are placed associative to the connector. An example of a user-defined cut list. Simply selecting a path will allow the editing of the path definition. Points can be added, moved or deleted. When a component is moved, the path retains its associativity and can lengthen or shorten to satisfy the attachment to the device. The path length can be locked at a known value. Now when the connector moves, the impact is shown along the whole path to maintain the path length. Moving a device by assembly constraints updates the connector and wire locations. Running the HD 3D tool for a routing checkmate test shows where violations of bend radius have occurred. Editing the route spline by removing points and reducing extension lengths repair the route. The routing design rule validation tool can locate errors in large harnesses. Running the HD 3D tool again clears the errors. After modifications have been made to the harness, the form board can be synchronized to reflect the changes. The harness can be substituted with a later version or the existing harness updated. Discrepancies are found and then listed and the route updated. The updated form board layout is reflected in the drawing. The new length values in the cut list are updated. Thank you for watching this presentation on NX routing electrical base and NX routing harness. Fully integrated within NX, NX Schematics is a 2D schematic capture application. It provides the ability to apply logical design to various systems including electrical, piping and pneumatics. NX Schematics not only captures the schematic graphic layout but applies attribute information to the components, connectors and connections. Existing schematics can be imported into NX and have the required attribute information applied directly to them. Library creation is simple and uses NX modelling and drafting applications to create the 2D symbols. Reporting functions include bill of materials, connection and component lists, as well as user-defined reporting. NX Schematics having full interoperability with NX makes the application suitable for aerospace, automotive and equipment manufacturing industries. Logical information can be imported into 3D routing applications to merge the logical information into the 3D environment. Connections can be identified in 3D and wire bundle diameters calculated. To start this demonstration, I will cover the basics of creating devices, connectors and connections. Graphics for these objects can be created on the fly, imported or retrieved from libraries. I will create the first device from scratch. The box command draws a simple rectangle and then prompts for required text attributes. This device represents a power pack and has a designation of PP with a text description of power pack. When required, additional attributes can be added, and in this case I'm going to add a supplier. Attribute information can be reviewed and edited. For the next object, I will show building the graphic from existing lines. These can be drawn in NX or imported from other systems. A rectangle with chamfers in the corner will now represent the connector. The Create Device from Curves command will allow the selection of curves, then prompt for additional text attributes similar to the previous command. The reference designator for the connector is CONPP. Connectors need connections, and these are drawn with the Add Connection Point command. The connector is selected, then the point and label locations. Connections can be represented by circles or point objects. Attribute information is displayed for the connector. The library command provides the interface to add devices, connectors and connections from a library. The location and arrangement of library files is mapped in the operating system. Folders are navigated through the upper panel. For my purpose, I have separated files into connectors, devices, switches and wires. The arrangement of folders is up to the user. From the lower panel, I will select a device. The icons represent parts held within the device folder. The circuit board device is added to the schematic. Next, navigating to the connectors folder, I will select a 16-pin connector. Graphics are defined in the library as a single file. When being added, the graphics can be rotated, mirrored and scaled to suit. A rotation of 180 degrees is required. If I wished to flip the pin sequences, I could also mirror about the y-axis. The graphics for the connector is defined using NX curves and text. Pin connections are defined and if required attributes such as terminal part numbers are added at this stage. In addition to the graphics part file, a text descriptor file is created. The information in this file defines the prompt for the library box, the location and name of the associated NX part file, the name, values, location and style of any default text attributes. The default designator for this connector is con1 and the text will be displayed with the graphic. The style of the displayed text is defined below. Other default attributes including part number, vendor and description are defined. The attributes on the connector can be reviewed and edited. I will change the reference designator to a value of con.cb for connector circuit board. Connections, in this case wires, are added through the library or by selecting existing curves. In this case I have a pick selection of colour as the differentiator. Once the wire is selected, I can define the connection type for ease of placement. Normal placement makes the longest axis of the line the first direction taken. Horizontal makes the x-axis the first direction. Vertical makes the y-axis the first direction. Direct connects the 2 points directly, whereas zigzag places an X or Y movement in the midpoint. I will now place a red and black wire. My default settings are to add descriptive text, naming the wire and its colour. Changing the drawing display from monochrome to colour can display the wire colours if required. Adding a device such as a switch can split the connections and prompt the user to rename the new added connections. Deleting the switch device will heal the connections. When moving associated text, the connection highlights to show the association. Before generating any reports, let's review the attribute information attached to the graphics. The device has information such as reference designator, part number and description. The connector has similar attributes plus the associated device being the controller. The connection includes the connection name, gauge, colour and type. The terminals have a part number attribute as they need to be reported separate to the connector for ordering purposes. The report definition files are user-defined text files describing which attributes are to be included. The first report generated is a bill of materials. The report can be placed on the drawing as a table or as an external text file. Now a connection list is added. Information includes the connectors, terminals and wires with their associated part numbers. To interface with the NX electrical harness application, a component list and net list can be stored as text files ready to import into the NX electrical navigators. The import of these lists is included in the NX electrical routing presentation.